All right, what's up, y'all? So let's look a little bit more at function transformations. Now, considering having this parent function, f of x equals x squared, if, like we talked about last time in the last video, if you to add or subtract to x, or add or subtract to the whole function, that means that you move the whole function left, right, up, or down. Now, these constants here, when applied to this function, will compress or expand or even flip the function around the axes. So let's actually watch and see what happens. So first, let's see what happens when you multiply. Let's see what this a constant does as far as like transforming the function. So say, for example, you had, okay, with this parent function, f of x equals x squared, let's say you had g of x equals, okay, 2 x squared, okay? So 2 is your a function whenever you have a constant multiplied times essentially the function. Let's graph that and see what it does. So remember, x squared is like this here. So you have 1, 2, 1, 2, 3, 4, 1, 2. So x squared has the origin here, and then at 0.1 here, 0.2, it goes up to 4. So 1 and 4. So this is f of x equals x squared. So let's see what happens when you multiply x squared times 2. Get a table of values. And I'm sorry about that glare right there. I need to figure out something about that light. Anyhow, so when x is 0, g of x is 0. And all I'm doing is plugging in x values into here to find what g of x is. When x is equal to 1, 1 squared is 1, g of x is 2. When x squared is 2, 2 squared is 4, and 4 times 2 is 8, so g of x is 8. Now let's go back in a negative direction. X is negative 1 squared is 1 times 2 is 2. When x is negative 2 squared is 4 times 2 is 8. So let's graph that and compare it to this here. Okay, so now you have, let's go, we went to x is 2 and x is negative 2. 1, 2, 3, 4, 5, 6, 7, 8. Now, so you have 0, 0, of course, x-axis, and then this is g of x. At 1, g of x is equal to 2. 1, 2, 4, 5. At 2 is equal to 8. Okay. Okay, let me see. And then here, at 1 is equal to 2. And 2 is equal to 8. So here we go. All right, so let's see what happened. And my drawings aren't perfect, but let's see. So when you multiply this by 2, it seemed to compress the function, because you see at 0.1 with g of x, this was g of x was 2. When x is equal to 1 over here, g of x is equal to 1. So this is when you multiply parent function times some constant a that is greater than 1, then it compresses the function. So to compress A is greater than 1. So you want to multiply it times some A greater than 1. And let me put a line here so we can see these notes better. So now let's see what happens when A is less than 1. Specifically, okay. So when A is, let's try 1/2. All right. So let's get our values. When x is 0, g of x is 0. When x is 1, 1 squared is 1, and then 1 times 1/2 is 1/2. When x is 2, 2 squared is 4, and then 4 times 1/2 is 2. Okay, let's go back the other direction. Okay, so when x is -1, -1 squared is 1, and 1 times 1/2 is 1/2. X is -2, -2 squared is 4, 4 times 1/2 is 2. So let's graph that real quick. Okay, so let's go 1, 2, 1, 2, and let me go 1, 2. All right, so the origin here, when x is 1, g of x is 1/2, so it's right here. When x is equal to 2, g of x is equal to 2. Okay, and then same over here, 1/2, and then 2. All right, so let's think about this. Now I haven't really drawn this. Let me erase this and try to draw it more to scale, so to speak. It's kind of hard to do it on a dry erase board, but I want to try to draw it like that so the points make a little bit more sense. So that was 1 and 1/2, and then 2 and 2. 1 and 1/2, 2, -2 and 2. So if you see that there, this isn't perfect, but I don't know if you can tell when with that being between 0 and 1, it expands the function. So to expand vertically, A is between 0 and 1. So when you have some number multiplied times the function A, then when that A is greater than 1, then it compresses the function vertically. When that A is between 0 and 1, it expands the function vertically. Now, so what if this was -1/2? Okay, so equation 0, 0. When x is 1, 1 squared is 1, 1 times -1/2 is -1/2. When x is 2, 2 squared is 4, 4 times -1/2 is -2. So when x is -1, -1 squared is 1, so that's -1/2, and that's going to be -2 again. So you probably already see what happened. 1, 2, 2. So 0, 0, 1 and -1/2, 2, 2. And then boom, boom. So you see, so flip across x-axis, or in other words, to flip it vertically. A is negative. Multiply times a -A. Okay. So let's talk a little bit about the effect of this constant b on a function. And of course, again, in our case, parent function is x squared. Now, what you'll notice is that a constant here almost works the same as a constant multiplied times the whole function a. So in other words, a constant b works very similar to a constant a as far as like compressing and expanding the parent function right here. But under certain circumstances, you can better see what the difference is. But let me just show you either way. All right, so say for example, you have, okay, so just to show the difference. So what we're talking about, okay, so if the parent function is f of x squared, f of x equals x squared, multiplying the whole function by a constant. So for example, if a was 2, that's like saying 2f of x, which is 2 times x squared. Now a function multiplied times x, or the argument, if b was equal to 2, that's just like saying f of 2x equals, again, looking at our parent function, that is 2x squared. Okay. And now, so let's see the effect again. How does the parent function look? So parent function f of x equals x squared is, okay, if you have 1, 2, 1, 2, this is x, this is f of x. Okay, so when the parent function f of x, when it's equal to 1, f of 1 is 1, f of 2 is going to be 4. So 1 and 4. All right, now let's see what happens in this circumstance when you have a constant multiplied times the x term. So we want to find, in other words, we're going to let that b be 2. So that's 2x squared. Okay, so all right, now I like to start out doing a table as always. So x values and then g of x. So when x is 0, g of x is 0. Okay, x is 1. 1 times 2 is 2, and then 2 times 2 squared is 4. When x is 2, 2 times 2 is 4. 4 squared is 16. So then we'll go back in the negative direction. When x is negative 1, that's negative 2 squared is 4, and then this is going to be negative 16. So graphing that, let me make sure I'm not around that glare. Okay, so 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. Okay, so the origin is here. Then that 1, 1, 2, 3, 4, and then that 2 is all the way up here at 16. So 4, 16. So as you see here, whenever you multiply the x by something that is greater than 1, it compresses it. Same way that it would if you multiplied the whole function by some constant that's greater than 1. We also saw that would compress it as well. Okay, so you can compress vertically when b is greater than 1. Okay, And then you can, the same goes just like we talked about with the A constant. Whenever it is less than between 0 and 1. If you so I'm not going to demonstrate that here, but you can kind of already see just if you go back and look at what we talked about there. If you let me see. If you want to expand it vertically, and you can kind of look at that yourself. In other words, just like let your B term be equal to like 1/2 or whatever, and you'll be able to see that it actually makes it fatter.